Hi folks, I'm back again with another video to showcase what Hexaview is doing in AI. In my last video, I shared how Hexaview created a web application using vibe coding for legacy app modernization. In that video, I showcased a platform where we converted legacy code into modern language. Today, I'm going to use Hexaview's AI first engineering approach to develop an enterprise grade production-ready order management system, not in months, but in weeks. How did Hexaview achieve that? Hexaview has come up with its own platform called Haki AI, which is Hexaview's AI knowledge integrator. Haki in Japanese means ambition, and Hexaview is ambitious to utilize AI to develop production-ready application and not just vibe code for demos. So today I'm going to share a use case of TOMS. It is called a trade and order management system, a system where billions of dollars are traded every month. Hexaview has created many trade and order management systems in the last 15 years. A trade and order management system is utilized by financial advisors to create portfolios, to manage them, to rebalance them against models or targets for order generation and for trading. We are all aware of Agile SDLC, right? We just modified that SDLC and now calling it AI-enabled software development lifecycle. This lifecycle will follow the same methodology, but compresses the entire cycle by about 7x to 10x. I want to share what an AI pod in Hexaview looks like. In general, I mentioned building a trade and order management system could be a 20 people team. We did it with 4 engineers and AI agents. How the AI engineered application looks like as compared to the traditional one. The screen that I'm showing you right now, it's a sample dashboard between a traditional application and AI engineered trade and order management system. The functionality is absolutely same, but the UI is more modern in the new AI engineered application. I would also like to share the project timelines with you, what we followed in order to create an AI trade and order management system. Let me share with you the challenges that we faced during the duration of this project. We started with certain goals in mind, certain KPIs in mind. Some of them we achieved, some of them we plan to achieve as we move to next phases. Right? This is how an accounts document was generated. What is the purpose? What is the scope? What is the functionality? How many sections will it have? All that was mentioned. Similarly, we had certain documents at the platform level. So to give you an insight, we generated 2 types of documentation. One at the application level and one at every module level. At the application level, we wanted to share what is the vision of an order management system. We want to share what are the best practices that we have followed traditionally in the last 15 years for the front-end application, for the back-end rules that we follow. So these are the design goals, these are the folder structures that we wanted, these are the naming conventions, what kind of technology framework we want to use. We created all that. This is a sample .NET, very simple, high level, what kind of .NET framework, syntax we follow. So I'm going to show you a sample prompt that we have used for the backend in order to generate a security and security type. These are big prompts, as we can all understand, because they do a lot of stuff in one go. You just give this prompt on cursor and just wait for magic to happen. Similarly, I have prompts for, this was a backend prompt, I have prompt for the UI, the UX that is generated. As you can see, this is like a 35-page document. And this is just a sample of prompts that we have utilized. We have utilized hundreds of prompts to reach to a level to generate a production-ready enterprise application. So this is a sample prompt. Simple, what is the system design prompts? What kind of data access do we want to give, right? What kind of relationships do we want to maintain? That's how we have actually given a lot of prompts, which also sometimes has some parts of our algorithms, our thought process, modules or interfaces that we talk about. Now let me show you how our cursor environment look like. On the right hand side, I have a sample prompt that I would like to run and show it to you. For example, we have something called neglected accounts, right? And we want to show a different color if the number of neglected accounts is greater than 50%. So let me click on run this prompt and it will automatically go and generate and run the prompt. Not only that, while running the prompt, it will also highlight the sections of the code that it actually modifies. And it gives me an option where I can accept or reject certain sections of code. Anything that is added by a cursor, it is in green. Anything that is removed is in red. And I have the choice to accept or reject. For example, when this whole thing is run, as you can see, it shows one file edited. There are 2 additions and 3 subtractions. If I click on it, I see all the additions and subtractions that has happened over the code. And every addition and subtraction I can either accept or reject. That is how we have done the coding, and sometimes we have also utilized it for bug fixing. Now if I run this application on my local, I would like to see and I like to show if I can show you how this application looks. Now the running application, as I clicked on run the application on my cursor, it is actually running the application. That's how easy it is to check what you have created. In the end, I would like to say that we just didn't build a TOMS component. We actually rewrote how enterprise software can be built using AI first engineering. Thank you.